All right, you want to talk about the algorithm, like how to maybe solve this stuff? OK, let me pull this up. I don't even think we need this right now. And nope. Nope, nope, nope. How do I do this there? That'll do. OK. Oh, nice. Display controls. Mute. Oh, come on. OK, I'm turning it off. Hold on. Exit. Turn off. OK. All right. Boggle. A, B, C, D, E, F, G, H, I, J, K, L, M, N, Q, P. We'll skip all, and we'll do it in a little weird order so we get the Q in there. This is going to say Q, U, maybe. Right? OK. So we have a board here that you're going to have to read into some function. What do you think is a good idea to read it into? Have any thought about this yet? Yeah. An array of strings. I don't know if that's necessarily going to be the best idea. What we kind of want to do is we want to model the data structure so that we know that like A is to the left and up, and B is to the up, and C is over there. So how might we do? We've seen this before in another lab, right? What do you think?
Do you use a nested dynamic array?
You can use a nested dynamic array. That's one definitely an idea, yeah. Yeah, I think a 2D vector might actually work a little bit. It would be easier. A 2D dynamic array is fine, but a 2D vector is going to be the way to do it, right? Inside the vectors, right? You can do a couple different. You can do it a couple different things. There's basically three different. I set it up to have a what do you call it? Well, let's just do the vector itself. You could set it up so that it's this. What is it called? Boglet, and bogword list. You could set it up to do that way. And the way we have that set up is, I'll have to bring that up on the screen too. But for now, let's just look at this. We don't actually need any of the other data about this if we do it in a two-dimensional vector. OK? So let's make first we'll make a vector of, we can define this like this. You can say vector, right? And then you have to put the little angle bracket. And then you put another vector, because it's going to be a vector of vectors. And then you put another angle bracket. What types of things are going to go in here? Is strings a good idea? Yeah. I think characters is probably a better idea, right? Characters, like that. And then you have to put a space there, by the way. That's got to be a space. And then you call it something. Like, let's call it the B board or something. Right? That will give you the actual structure that you can do this. Let's figure out how we could first read this in from the thing. Now, do you guys saw the format of the different files? It looks like this in a text file. 4 on one line, and then A space B space C space D, etc. OK? Yeah. Okay.
Are the height and width ever going to be different?
They could be different. You have to be able to cover every height and width, but you make it generic enough, it'll work fine. There's 5x5s that actually are on the web page as well. OK, the other ones.
Sorry,
yeah.
I mean, like, could it be like 4x5?
It could be. Yeah, it could be 4x5, but you won't be able to test that on the website. But you can test it otherwise. Yeah. I think we'll probably stick to square mostly, but it shouldn't matter. It actually shouldn't matter at all, really. Right? OK. Let's figure out how to read this in. OK. How are we going to read this in? We're going to need some variables for the height and the rows and the columns, right? That makes sense? How about this? Int rows, cols, like that. That's going to be part of it. Now, this can be in your class or in your. I'll let you guys work on the details of that. But this is we're going to just kind of write the main, like, try to how to figure out how to get this into the system. OK? All right. So the first thing that's going to get to you in the file, if we're piping this in from CN, is what? That's the row. OK, so we're going to get the row. OK, so we could do something like this. C in, right, like this, rows, right? And then C, or I guess you could do it this way. I think you can do, well, I don't remember if you can do it that way. I was thinking you might be able to pipe another one in there, but it doesn't really matter. OK, that'll get you the rows and columns. And then how are we going to read the rest of the board in? Yeah?
Then you can do a nested for.
Yeah, for int I equals 0, I is less than rows, right? I plus plus. Let's see. The rows is going to be the outer loop, right? Because you're going to read this one character by character for the column. So the rows is going to be the outer loop. Then you're going to do something similar for the inner loop. Actually, before we do this, I'll write a little space. For int j, I'll make it, instead of I, I'll make it r and c. So r is less than rows, r plus plus. And then down here, columns equals 0. Columns is less than, c is less than cols, c plus plus, c plus plus. There you go. All right. All right. And what's going to happen in the middle here? What do you have to do?
You have to create the vector.
Yeah, you have to create the inner vector, right? Yeah, you have to create the inner vector, which is just going to be a bunch of characters for the column, right? So maybe something like vector, right? Angle bracket char, and then we'll call it row, right? Because that's our row. This is very similar to the lab on the Photoshop sort of stuff, right? Very similar. OK, we do that. And then we just start reading things in. Yeah?
I don't really understand what vector we're making there.
This is the first. This is going to be the first row.
Okay.
Right? We're going to, each time we go through the outer loop, we're going to make one new row. And then in each row, we're just going to do this. We're going to say, you could probably do this. You could say char, I don't know, let for letter, right? Char letter, and then c in let, right? And then I'll move this up to here. Sorry for the thing, but move that up there. C in let, and then for each letter, where do we have to put it? In the row, right? So we just say row dot push back let. OK? And that will be the end of the inner for loop here. OK? Before we get done, before we get to the next inner for loop, we've got to create a whole new row. But where do we put we're going to create a whole new row. Where do we put the original row? We put it in the big one, right? So we've got the big one, which we define. I forget, did I miss defining it somewhere? Oh, it's right here. Sorry. There. B board, right? You're going to now push B board, push back the row. OK. And that will read in your whole board. Yeah?
I think on the PDF, the Boggle board thing you gave us didn't have spaces between the letters.
It should have. So it does. If you look at the actual ones, it should have. Yeah, it does have. So you can use cin, because it does have spaces so that each character is separate. Yeah.
Would it make a difference if you use getAchar?
I'm not sure how getAchar works, but it probably wouldn't make. It would make a difference because the spaces are going to be another character, right? So you do have to be a little careful there. You can try it, and you can make it work for the input data. The input data will always look the same, so you can figure it out. But I think this is just the easiest way. OK. So now you've got a board, right? Can I erase this? Yeah.
So it knows, the CN knows to stop or right after it sees one letter.
It sees one letter and it stops. Yeah, because it's asking for a character, so it knows how much a character is. Yeah, it'll ask for one. Oh,
What about with the QU?
that's a good point, though. Hold on. The characters, if there's spaces, you're right. If there's spaces, it's not going to do that. Hang on. Let me look at the. You might be right about the data. Let me just.
File that I'm looking at is just like 4 times 4 1.dat doesn't have spaces.
It doesn't have spaces. Hang on. Data. Sorry if I got that one wrong. Let's see. 4 by 4 dash 1. Is that the one you're looking at? Oh, you're right. No spaces. So you're absolutely right. Sorry about that. So this will work on no spaces. Probably work with getAchar if you have that one as well. But yeah, sorry. It's no spaces. So my fault. I was thinking it had spaces in there. But no. OK. So this is actually easier. Yeah, Hannah.
But for Q, that's the one you said, like,
Q is just going to be represented as a Q. Not so. It turns out that there is no Q in a Boggle board. It's always QU. So you don't need to worry about the fact that there's a difference. So that's actually a nice thing. So yeah, Qs are always just going to be Q in the actual board itself, or in the file. So that's good. OK. OK, we cleared that up. Now, can I erase this? Anybody still working on this? OK. Once you've read the board in, you now have a vector, which we've called bboard, which can instantly find any position on the board. OK, so bboard 0, 2 is going to be row 0, column 2. So it's the C right here. OK, and that's how you can represent it. And this is how you're going to traverse this somehow. OK, you don't need to have any extra information. You could, but you don't have to. You could use the Boggle struct to do this, but you don't have to, which is kind of nice. OK, all right. So now we've got the board in there. What is our strategy for finding a word? Oh, by the way, we have to read in the dictionary too, which I'll have to show you that too. But the dictionary, let's pause on that. Reading the dictionary is actually not too hard. You just basically read one word after the other until you see a period, and then you stop reading. And each word goes into this dictionary that we've given you the try for. If you want to write your own, by all means. But I see some no. I don't remember. All right, but you just stick the words in there. But so now the words are in a dictionary, and there's some functions that go along with that. But let's just figure out how we might traverse all the different places in this. OK, how would we do that? Any ideas? How we might traverse this? We've seen something like this before. Do you remember the maze lab? How did we do that? Yeah, Hannah?
I mean, from each place, you can kind of, depending on, as long as you keep in mind the limit of
Yeah.
the board,
Yeah.
you can just say x plus 1 or x minus 1, y plus 1, y
Yeah,
minus 1.
exactly. Now, I think it's I think it's kind of clever to do it this way. Watch this. Well, first of all, you're going to go through all the letters in the board, right? So another nested loop is probably a good idea. Same as before. I won't write the whole nested loop out. For R, we'll call it, right? We're going to go in the rows. And then, well, we'll call it rows. OK? And then for columns, we're going to do the same thing. And now we're going to be able to, now we're going to go through every letter. Because don't we have to start on every letter to check every letter? At some point, we have to start on every letter and do the checking, right? OK, so we're going to do that. And then we're going to try to go through each, we're going to have to go through each position in here. So from F, look at all the different directions we can go from F. We can go row -1, column -1. We can go row -1, column. We can go row -1, column +1. We can go row itself, column -1, et cetera. There's 1, 2, 3, 4, 5, 6, 7, 8 different ways we can go on this, right? So it's going to be a little bit intense in terms of checking everything. But if we do it nice and recursively, we'll get it all done, right? So we're going to go through all the letters. And we need some more, we need to be able to, we're basically going to call some function, right? Some recursive function. I don't know, what do you want to call it? Call it find word or something? Find word. Right? And what are we going to put in there? What do you think?
Probably maybe the location.
Yeah, how about that? You could do it. You could do it a couple different ways. You could probably just put the location, right? So in this case, it's going to be like R, C. You may need more information though, right? Because the find word is going to have to keep something along with it to say how far along in a word it's going, right?
A string.
Yeah, maybe a string. There's a function called isWord. I might be getting the capitalization wrong, right? IsWord, like it's dictionary. Your dictionary isWord, and you pass in a string. There's another one that's dictionary.isPrefix string. This might help you. What's cool about a try, and one of the reasons we love to use a try for this project, is that it's so easy to figure out if a word's a prefix, right? You just basically find it and don't worry if it's a word ending or not, right? You don't care. You say, is it in the try at all? Then it's a prefix, right? So that might be an important one, right? So I like the string. Maybe call it prefix or something. I mean, it's up to you, but you can call it something like that, right? C, comma, and then there's a string. We'll call it prefix, which is a string. OK, that may be enough for now. OK. We find it. What do we do if we find it? You guys have to figure that part out. But when you find it, you can say, this is going to hopefully return what? A Boolean, right? So, if find word that, then we actually, actually, I think all you need to do is, well, you need to either store it in that bog word, what is it called? Bog word list, or you can just print it out. But it's up to you. But you have to somehow just deal with it in some form or another. But at this point, if it returns true, then we found a word. Right? And this is where the beauty of the recursive solution is going to come in. You don't have to do this recursively. This happens to be pretty easy if you do it recursively, I think. OK. So that's it for your main find all words function, if you want to call it something like that, right? That's about it. OK. Question, yeah.
I guess my question with prefix is, for example, if a word has to be 3 letters long
Yeah.
in order to return it, at what point
Yeah.
is that?
How about this? OK, if find word RC prefix and prefix is greater than 3, we found a word, or greater than 2, we found a word, right? You have to do it. There's a little logic in there to figure out, hey, it is a word or not. Because we will find words that are 2 letters long. The dictionary, I don't know if the dictionary actually has 2-letter words in it or not at all, but you probably should make that check.
Yeah.
Pretty easy to do, right? OK, so we found a word if it's in the dictionary, and to do that. OK, so let's think about our recursive function, right? I mean, what is find word going to actually do? It's going to return a bool, find word. Right? We said we're passing it in an int r, int c, and a string prefix. OK, so that's what it's going to do. OK, so there's a bunch of cases here you have to figure out, right? There's a bunch of base cases in this case. All right? Yeah, go ahead, Julia.
Why would you want to pass in a string instead of a bog word?
You could totally pass in a bog word. Yep. If you want to pass in a bog word, that's perfectly fine too. You just don't have to use bog word if you want to, if you don't want to.
If you were to pass in a bog word, would you have to at some point make a string?
You'd have to make a string out of it to pass it to the dictionary, because the dictionary doesn't take bog words. I suppose you could update the dictionary to take bog words if you wanted to, but yeah. But yeah, you would probably have to do that. Good call. OK, so we've got this in here, and we're gonna have to find some corner cases. All right. If we just do it this way, if we just do it this way, we can make the corner cases. We can take care of almost everything right at the top, right? What if we're out of bounds? Can we return false if we know we're out of bounds? That's not going to be a word if we've gone out of bounds, right? So I'll just do this in kind of pseudocode for right now. If out of bounds, right, false. We're going to return false. So that's one thing you might want to check. OK. What would make us return true? The word's in the dictionary, right? So if the word is in the dictionary, and by the way, if you wanted to, here's where you could check if it's 3 letters long or not. If the prefix is less than 3, don't bother checking. If the size is less than 3, don't bother checking if it's in the dictionary. We don't even need to. But basically, if the word is in the dictionary, true. OK.
You mean before the word is in the dictionary, check if it's more than 3 letters?
Yeah, sure. Totally up to you, but you would probably want to do it that way. Yeah, don't bother checking if it's in the dictionary if you know it can't be a legal word. It's just not worth bothering to check, right? OK, so we've got that and we've got that. And by the way, our first prefix here should probably be something like the empty string, because we don't have anything yet. We know a position, but let's just pass in the empty string, because we'll use that position next, right? And the dictionary will say, no, empty string's not a word. OK. All right, and it's also less than 3 characters long anyway. So that's it. OK, what other kinds of concerns could we have here? Like we know that if it's out of bounds, it's false. If the word's in the dictionary, it's true. What if it's what else could we check? Remember, we've got 2 functions here. What else could we check? What if it's not a prefix yet? What if I said, if I started going A, B, C, and A, B, C is not in the dictionary, right? If I just get, maybe A, B something's about is in the dictionary, certainly, right? But maybe A, B, C is not in the dictionary. So if it's not a prefix, what are we going to return? Also false, right? So you can work on the logic of this, but I mean, you just got to think of all these cases, right? Word is not a prefix, false. OK, so now the word's not a prefix and it's false. OK, so let's see. So if it is a prefix, then we need to check other things, right? So if it is a prefix, and it should return that empty string is a prefix. I believe it does. I'll have to find out and check. But I think it says that the empty string is a prefix, right? If it is a prefix, what are we going to do? Yeah. That's good. We've already checked if it's a word, right? But if it's a prefix, now, by the way, we haven't actually added any characters yet to this string, right? Yeah. Not yes, but first you got to do something else, right? First we've got to say, OK, let's increase the let's see. How are we going to do this? Are we going to increase it first, or are we going to add to it first? I think maybe we should do this. Maybe in between here. Why don't we do this? By the way, this should say prefix in both times, right? If prefix, prefix. Before here, we haven't actually added the character yet. Let's add a character to this prefix. Which character are we going to add? The one that, well, whatever the row and column we got passed in is it, right? So let's do that. We do have to check if it's out of bounds first, because you can't get one. If you go out of bounds, you can't check. You can't put a character from out of bounds in, right? But once you've checked if it's out of bounds, you might as well put the character in, right? So something like prefix, I'll abbreviate, equals prefix plus the Bogboard, which hopefully will be part of the overall class, bboard. It's just a terrible. I'll write it up here. Whoop. There we go. OK, so we'll do this. We'll say prefix equals prefix plus Bogboard at row column. OK, so that just added on the one extra letter. So far, so good? Now, if the prefix is in the dictionary, we know that we've got a word. Done. OK? And here's the other thing. We can't just return true, by the way. We can't just return true. There's kind of an issue here, right? So this may be a good chance to return something else. Maybe we should return, it depends. If we return true, we don't know what the word actually is, do we? Right? So that's a problem. We know we found a word at that character. So maybe we can have another structure here, right? Another structure that is bog words or something, or just a vector of all the words we found. Because that's part of, well, we can't do that either.
Update the vector of all the words.
Yeah. We can't inside this function. Not here we can't. But over there we can. Yeah, we just have to be a little bit careful, because remember what we have to keep. The thing is about this, we have to keep the position of all the letters in the word. So this is actually probably a good idea to keep instead of and in addition to passing the prefix, let's also pass like a bog word, I guess a bog word itself, right? So maybe pass a bog word. And a bog word, for those who haven't looked at it yet, a bog word is made up of first you have a struct, which is called a boglet, right? And in the struct, I believe you have a row, a column, and the actual character. I think that's all that there is in the struct there, right? You've got a int row int column char c or something. Oh, well, it doesn't make sense. Row column and char. Is it c? So what's the int?
Call.
Is it col? OK. Col row col and char c. OK. So and then that's a boglet. A bog word is a vector of boglets. All right? That's that. And actually, what I did was I've type defed it, meaning that we say type def bog word vector that, which means that whenever you say bog word, it means a vector of bog letters. Okay? So if we pass a bog word in to there, then we can return the bog word, which will tell us the exact word that we're looking for. Okay? So I think we're going to want to update this a little bit. Right? It's not just that we found a word. We could, let's see, could we return we could return the bog word, or even better, let's just return. We'll return. You may not even need to return anything, in fact. To tell you the truth. Probably doesn't even matter. Although, if you do return it, then you know to put the bog word in the bog word list. So probably, yeah. Yeah, Julie?
Well, I was going to say, can you just push it onto the bog word list?
Yeah, you totally could.
Turn a line after that?
You could do that, but I mean, how about this? If we found the word, then we know that the bog. So before we actually find the word, let's create a boglet or a bog word, BW or something, right? And then let's pass in the bog word as well as the string. OK, it's getting a little more advanced, but it seems like it's OK. We're going to pass in a row, a column, a prefix, and a bog word that we're going to keep passing the bog word so that we make it bigger, bigger, bigger. If you wanted to, you could probably dispense of the string and make it all a bog word if you wanted to, but it's up to you. Yeah, it might be easier to deal with a string. Let's see.
Would you be able to pass out more than one word then in order to find like bunch?
Well, that's a good question. Let's see. What if you find a bunch? Yes, that's a good point. So instead of taking care of it and putting it in the bog word list here, when we find a word, why don't we do this? Put it in the bog word list, then return true. That's a good call. OK, yeah, that's a good call. So if prefix is in the dictionary, so we're going to do two things. We're going to, one, we're going to put word in bog list, bog word list, sorry for the small handwriting, bog word list. We're going to do that, and then we're going to return true. Sound good? And in fact, you may not even need to return true, as it turns out. You might need to make this boolean, just make it void if you want. In other words, this recursive function is going to handle putting in the word into the bog list as well. Because you're absolutely right. Words can be made up of multiple, like you can have, I don't know, ABE and ABEJ or something. So multiple ones will fit in. That's a good point. Yeah. OK, so we're going to do that. All right. I think we're getting there with this. We do have to include a bog word as well in our definition. OK. And then this is the part that's interesting. If it's a prefix, we know that we've got to, or if it's a prefix for some word, we know we've got to keep checking, right? So from F, we said there are 8 different directions to check. If there's 8 different directions to check, you can check them all. Now, can you make this into a fun for loop, a couple for loops to do that? Probably, right? You could do go left and up, go right and up, go right, go, you know what I mean? You could do that. Or you could maybe do a couple for loops to figure that out, right? There's 8 different directions. You're going to go 3 in each, or 1, 2, 3, 1, sorry, there's, 1, 2, 3, 4, 5, 6, 7, 8. So you're going to have, let's see. I think a clever way to do it is to go, what's this one? Row -1, column -1? So how about this? For I equal, we'll call it another, do we have an R? Yeah. Let's say, I don't know, we'll use I. I equals row -1. I is less than row plus 1, right? That would do it. That would give you 0, 1. Would it give you 2 or 3?
You might have to do row plus 2.
Yeah, I think it's going to be row plus 2, isn't it? Because you've got to go row minus 1. If row is 3, we want to check row minus 1. We want to check row, and we want to check row plus 1. You could do less than or equal to row plus 1 if you wanted to, sure. Yeah, to make it a little more clear. But that's going to be one loop. And then are we going to have an inner loop too to do the columns? Same thing. For j equals column minus 1, j is less than or equal to column plus 1, j plus plus, forgot the r plus, or I plus plus. Right? OK. And what are we going to do?
What? You gotta check to make sure it's inbound.
No, we don't. We're checking that in the function once the function's called.
Call the recursive.
Call the recursive function.
But you can't call it if I equals 0 and j equals 0 because then you're.
Yep, you're going to the same place. You can't use a letter twice. You're right. So if I is not equal to j, right, then we're going to recurse through this. Right? And recurse is really call find word, and we're going to do j this time by I by j. And then we're going to pass in the prefix, which we've already updated. Hold on one sec. We're going to pass the prefix in. Then we're going to pass in the new bog word, which, let's see. I guess the bog word should be updated here, too. Update the prefix and update the bog word. And then we're going to just pass the bog word. Right? And that would be it. Yeah?
How do we know that we're not checking on a letter that we've been on before?
Let's see. How do you know that you've... Oh, yeah. We do have to check that, don't we? How could we do that? Yeah.
You could, I mean, then the parameters get kind of messy.
Another parameter.
You could add another parameter from where you came.
Yeah, which is going to be full of what? Could be full of what? This would be interesting. Yeah, this is a good point. Another boglet. Boglet, right? Or a vector of boglets, I should say, right? A vector of boglets, which you update every time you get to one. If it's not out of bounds, we're going to do 3 things up here, basically. You could put this in another function if you wanted to, right? I wouldn't. Probably get ugly. But you're gonna update the previous. You're going to update your bog word, or even better, you can just go through your current bog word and check if you've already got those numbers in there, right? Wouldn't that be even easier? You don't need another function. Just go through the current bog word and say, is my current position in the bog word already return? Right? Return false.
After the previous.
Well, let's see. If you're out of bounds, you definitely want to return. That's a definitely hard case. But the next thing we want to do is, why don't we check, and not only if we're out of bounds, but if the bounds are, or if the current letter is the one we've already been at for this word, right? So that's where we're going to have to do that. Yeah, very good call. Very good call on this, right? You got to do that. So that's going to be, I would just go through all the letters in your bog word, because you've got a bog word that gives you all the different positions, right? Go through all those letters and say, I've already been here. If I've already been here, goodbye. That make sense? Yeah.
I kind of have like a larger question that kind of relates. You know, we used like a char and then vector, like a vector of
Yeah.
chars. What if we use like a bog word list to represent the Boggle board? Then would that work, or because then we would have to keep passing rows and columns because it would be stored inside the bog list.
Well, you still have to know which one you're at, right? So I mean, either way, you're right. I mean, you could make a bog. Well, you could make the Boggle board out of boglets, sure. But the problem is you don't need to, because inherent in a two-dimensional vector is the position, right? The position's already there, so you'd be kind of duplicating the effort there. Yeah, not too.
So you update the prefix by adding whatever you're on already.
Yeah.
And you update the bog word by adding something else.
Yeah, let's do that. So what I would do before you even update the prefix, let's make sure we're not at the wrong position. right? Let's say we're not in the wrong position. So for, I don't know, another I is fine. I equals 0. I is less than bog word size, I plus plus. We're going to basically go through the whole bog word, right? And if row equals, is it row r, whatever we had there. If r equals bog word I, that's the character, dot row, and c equals bog word I column, return, right? Return false. This is to check if you've already been there, right? So you check if you've already been there, and then, yeah, you had a question.
Would it make sense if you added just to the struct a bool that said true or false, and you updated the bool in the struct for the boglet?
What would the bool tell you?
If you've been there already. So in the struct for the boglet, you have.
Oh, instead of doing this check?
Yeah, you just and then you just update.
If you want to, yeah, you're welcome to do that. We're not going to take. I would not take points off for that. Sure, if you wanted to, you could do that. I mean, it's if you've been there or not. Yeah, it seems like it's kind of a waste for some of the other times because you only need that when you're doing the solver.
Right.
But you could do that. Question?
Why is it BWI?
The bog word, remember, is a vector of bog letters. So you can represent it by each letter is another index in the bird. It's a vector. It's an array. Just an array. Think of it under the covers. Okay. All right. So that would do that return false. Then you would go update the prefix and also update the bog word. Well, let's look at how we update the bog word. Right. We update the bog word by doing. We would say something like this: bog word. Let's see. We want to do the last one, so we could do bog word size minus 1. You can also do, I believe it's bog word, is it back? I think, oh no, I'm sorry, you can't do this. What am I doing? You can't do that because it's not a regular array. You're just going to do bog word push back your bog letter, which you have to create as well. Okay, so you have to create a bog letter to do that. Well, creating a bog letter is easy. It's just got a row, a column, and it's the character, right?
Where is it?
So this is right after you've checked that you are not at, you haven't reused this letter already.
And before the prefix.
Doesn't matter, either one. It's before or after the prefix. But the idea is push back the bog letter. So we better create a bog letter. OK, how do you create a bog letter? Sorry, my board's all over the place here. But a bog letter, right? Bog letter BL, we'll call it. OK, and then you just say BL dot row equals R, BL col equals C, BLC equals the board, bog board, at position RC. Right? That creates your bog letter. And you push that bog letter into the and you put that bog letter into the bog word, and now you've got one more letter in your bog word. Okay. All right. So I actually think we're pretty close right now. Yeah.
Oh, sorry. So do you also have to pass in a bog letter to the find word function?
You can do that. Now, we talked about this a little earlier. You could pass the bog letter, which has the position inherent in it, right? You could do that. The problem, that would work. You could do that. You could pass in a bog letter instead of passing R and int. You just pass the bog letter in there. That's fine, too. You don't have to pass the row and the column. That would happen back. That would happen back here, right? It would be, you'd create a bog word, you'd create a bog letter from R and C. You'd basically be doing this up here,
Okay.
right? So either way, it'll be doing the same thing. Okay. All right. So we've now, let's look and see if we can. Let me do this. Put some better letters in here. R, M, P. That would be terrible letters to put in there. R, M, another E would be good. OK, so we can find this gem, G-E-M. That's how you spell gem, right? Let's say we find some other one, too. What's that?
Peg.
Which one? Head?
Peg.
Peg. P-E-G. Right, that'll work. Pen is also one.
H-E-L.
Are there any four-letter words in here?
Germ one?
Which one?
Help.
Help. H-E-L-P. OK, germ would work, too, wouldn't it?
I don't think germ.
Oh, germ. There's no R. Germ doesn't work because it's G-E, skip. You can't skip that one to get there. Yeah. Let's see. I wanted to find one that's two prefixes to see if we can walk through this.
Need more vowels.
What's that?
Need more vowels.
I know. I knew our vowels. How about this? How about we just come up with one? Let's see. What's a good word that has that is? It can be an S on the end, right? I don't know. Top and tops. We'll do it this way, right? R, L, M, Q, U, S, P, N, and J or something, right? OK, so let's see if we can find top and tops in here. Let's see if this works. OK? All right. We're going through here, blah, blah, blah. We're checking everything. Eventually, this will get to the T, right? It will definitely get to position 0, 1, right? OK. And we're going to go into our find word. And what are we going to pass in there? We're going to pass 0 and 1. And we're going to pass an empty string for now. And we're going to pass the bog word, which we created, which is empty as well. OK. We get into there. OK. Is position 0, 1 out of bounds? It's not. It's fine. OK. Let's see. We are going to check through our bog word. Our bog word size right now is 0. So we don't need to even go through this at all. So we will not return based on having already seen the letter. Then we push back we create a bog letter, which has the row 0, the column 1, and its bog board at row column. So that's going to be this one letter right here. Goes into our bog letter. Then we push back our bog letter. So far, so good. OK, we've got our bog letter now. Then we create our prefix, which is going to be, actually, since we've got a bog letter, we don't need to do that anymore, right? We can just say BL plus equals, or pre equals pre plus BL dot C. That would do it, right? It's already there. OK, so now we've got that. So we've got a, let's write down what some of the things we've got right now. I just said instead of grabbing it from the board again, we just grabbed it from the board here. And we know we've got a bog letter. Just make it a bog letter there. OK, so we've got a bog letter, our bog letter here, which is going to have 0 and 1 in it for the row and column, and then the letter T. So far, so good? OK, and we've also got a prefix, which is going to be T. OK, so that's what we've got right now. OK, all right. If the prefix is in the dictionary, so in other words, if the prefix is, the word is in the dictionary. So it's not even just if prefix is in dictionary. It's if dict.isWord prefix, right? If it is a word, is T a word in our case? No, we're going to say T is not a word. OK, all right. So it's not that. If the prefix is not a prefix, is T a prefix for some of our words? Sure it is. So that's going to be OK. So if it is a prefix, then we are going to do this business here, right? So we're going to start going through these things and looking. Well, we're first going to look where? If we start here and we look at, if we go row -1, column -1, we're going to try to look out here. We're going to call it again and immediately return false, right? OK, but then we're going to keep going through here. And we're going to look again, right? And we're going to look here and T, and that may find a word, but we don't care about that one right now. And then we're going to look here, and that may find a word. OK, we don't care. This one's going to return immediately. This one's going to, we're going to skip this one because we've already been there. Oh, where did we forget to put? We were going to put that in there, weren't we? Oh no, we don't. Yeah, we checked it here. That would fail because of this, right? That would return because we've already checked ourselves there. Okay, or actually, it wouldn't even get there because we skip it to begin with. That's where it would actually go. Skip it to begin with. Okay, then we're gonna check the O. Okay, let's see where this one gets us. Okay, so what have we passed in here? We have passed in our bog letter. Or sorry, we have passed in our bog word, which we pushed back. So we've got our bog word, which is gonna. I'll do it this way. Bog word is gonna hold this guy and other things here, right? Okay, our bog word is going to hold this guy, or this set of bog letters. Okay, so we passed our bog word in there. We've also passed the prefix in there. Again, you don't have to if you don't want to. And then we passed in a new row and column, which is going to be O, which is going to be 1, 1. Okay, thinking like that we just went through this exact scenario for T, aren't we going to end up with pushing another word on here, 1, 1, and it's going to be O. And that's going to be part of the bog word. And now our prefix is going to be TO, right? And we are going to check and see if and then we're going to continue doing the exact same process again. Yeah?
What are you passing in as the prefix when you get to the O? You pass in,
This prefix that we just created.
oh, so the prefix is basically non-bog letter representation.
Right, it's just a string. Now, as Julia said earlier, you could take a bog word and turn it into a string. In fact, you might want to write a little function. Instead of passing this whole prefix in, just have a function that says bog word to prefix,
So the prefix
to string.
is just for the dictionary search.
Yeah, it's just for the dictionary searching. Yeah. Kate.
When this goes back through for O,
Uh-huh.
and it creates another bog letter for O,
Yeah.
it's okay that it uses the same name because it's in a different function.
Different function.
Okay.
Yep. It's but the bog word is going to be the same bog word, right?
Pass it.
Yeah. And by the way, when you put it in the vector, it makes a copy of it for the vector. So the vector has its own copy of this guy. Okay. All right. So then we're going to do that. And 2 might actually be in the dictionary. This is where you might want to check and see if it's less than 3 characters. Is that what you're going to ask?
Yeah, I was going to say
Yeah.
where exactly, can you just clarify, it then puts in that shorter word and continues to go and find tops?
Well, it doesn't. So it won't. If the prefix is in the dictionary and it's greater than 3 letters, for instance. But I don't think there's any 3-letter or 2-letter words in the dictionary, actually. But we'll have to check that and see. But this is where you do that check. And either you'd put it in the bog word list or not. And when you copy it in the bog word list, the nice thing is it makes a copy for you. So the vectors will do that for you. So you actually get the copy. OK, so now we've done that. My argument stands that if we get O to work, then we'll do the same things again. T will return because it's already checked it. O won't even get checked. The others might return words, but we don't care about that one right now. And then we get to top. And so then we do the same thing happens. We get a top in TOP in here. And that's going to be at 2, 1, 2, comma 1. OK. And it's going to be the same exact process. OK. But right now, top will go into the dictionary, right? Or go into our bog word list. Top goes into our bog word list because it is in the dictionary. And it's greater than 3 characters long. But that doesn't stop us from finding more. Right? What stops us from finding more is, let's see. Here's what stops us from finding more. We didn't check this before, did we? Right? Oh, no. If it's not a prefix, that's when it will stop, actually. Yeah, you're right. We don't need to check that. Once it's not a prefix, it will stop. Right? And it might go through the whole board before it gets to that prefix, but it'll stop eventually. Because there won't be anywhere else to go. And it's not going to be a prefix. Yeah?
If prefixes in dictionary
Mhm.
conditional statement, is
Mhm.
there a return true there? Because if there is, then how would
There's not a return true. No, you won't do a return true there. No. Now, I'm actually thinking it would be interesting to see so some of the words in the dictionary are more than 16 characters long. So which means that you could go through all the letters, get to the end letter, and have it keep trying, and this will fail every single time. And it does that. Did that help?
Yeah.
OK. The rest of the video should be a little better. But if you keep doing this, then all of a sudden you have to make a check to see that you haven't used all the letters. I think there's probably one other check in there. If your prefix is equal to the size of the board, then stop, because you're done. You looked at every letter and you don't find any words if it's not a word. Yeah?
I think I'm missing something obvious, but how does it start checking from another new letter?
This is where it starts. The original function, it checks from another. It checks all the letters in the board by doing this.
Okay, so
Yeah.
you have to go to like the solve function again.
Yeah. Well, right. This one goes to the find word. The solve function is we'll do this for loop for all the rows, for all the columns.
Oh, right,
check all
right.
the letters. Yeah. Now.
So for top and tops, like both are in the dictionary, right? Like how do
Yep.
you store that word?
Yeah. So we've stored. We're going to store top in our bog word list. So our bog word list is a two-dimensional vector of bog words. So it's a vector of bog words. Okay, if you look in the .h file, it's a vector of bog words, which means you just push it back onto the bog word list. Push the entire bog word onto the word list. Now, our bog word list will have both top and tops.
Okay.
Right? It'll get pushed on twice. It'll get pushed on first when it finds that it's in the dictionary, but doesn't return. You're right. Puts it on the dictionary, but then keeps going, right? And keeps on going. And then you need to just stop when it's not a prefix or when it's reached 16 or however big the board is. Yeah.
This is just like a logistic question.
Mhm.
I assume that like we can add as many parameters as we need and like as many
Yeah.
functions as we need.
This is a pretty open project in that sense. You can add as many as you need to this. It's going to have to be somewhat fast. I mean, we are going to test it on some big things. In fact, I don't know if my solution is particularly fast. This recursive one is not going to be slow. It's pretty extensive. Like it goes through. I mean, it has to check everything, but you really do have to check everything. Not much more you can do than to at least start checking everything. You want to be able to return quick. You want a lot of cases to turn. If you're out of bounds, if it's not a prefix, get out of here. Because there's no point in keeping checking if it's not a prefix. Yeah.
Do you then have to copy that bog word list, or can you use that when you go through, like, I guess the next step would be scoring and checking?
You can't, because it's 3 separate programs. So you just have to recreate some of this as well. But remember, you're only doing the solving once. Some people thought maybe we saw in the checker, maybe we should solve and then compare against the solver. Not the best solution. I think the best solution is, which we'll get to in a minute, how do you determine if a word is in the dictionary and if a word is legitimately on the board? Okay, so I think, although the code's all over the place, I think we pretty much got it to this point. Like that's probably the way that we'll do a pretty good job there. Any other questions on the solving part? Nice and recursive. Okay, you want to go over the yeah.
I mean, there's one issue. You keep checking if it's out of bounds a lot.
Yeah.
I don't know if that eats up a lot of time.
Well, so you're going to check any of the side ones are going to get lots of checks out of bounds. Yeah, that's true. You could do what? You could, instead of calling the function down here, you could make the out of bounds check up here. Or you could make the out of bounds check right here. If I is not equal to j and you're not out of bounds.
But if it doesn't eat up
It'll eat up less function. You'll have to call less functions. That's it. See you later. Okay. All right. Yeah.
How does this is not so related to this kind of, like how does after you read in the Boggle board, how does that get translated to the website?
It's kind of the other way around. The website passes the Boggle board to you.
Oh, okay.
Thanks. I'll see you later.
So it knows the Boggle board and gives you the Boggle board.
Yeah, it gives you the Boggle board. You remember, you read in the Boggle board, right? You read it in from standard in, so the website passes you that through standard in, as it turns out. Yeah, kind of neat the way that works. Okay. All right. You want to go over some of the other algorithms? Yeah. Okay. Let's look at. Let's do this. I'll leave the board up there for now. We're not going to really want this right now. Well, we might, but we'll redo what we have to. Okay? So basically, what's the strategy going to be if I give you a list of words? Top, tops, and I don't know, some other thing in here. Bat is one. And then I give you some that aren't words, like JSM or something like that. What's the strategy going to be to figure out if it's in the board or not? This is what we have to kind of figure out. Yeah?
You like pick a word, you pick the first letter, you go to the board, find the letter. Or I guess you could take the first letter of each,
Mm-hmm.
and then go through the board and compare each letter to all four of them. So you don't have to go through the board over and over again.
Could do that. Yeah, you could do that.
The array that you were creating, like.
Can't use any of the other arrays. It's a whole new process. All you get is you get the dictionary, you get the board, and you get the list of words now, right? You could go and solve it and then check against each solved word, but that I wouldn't suggest that. Probably not going to be quite as sufficient. Fast.
You compare to the dictionary, and then in terms of it being a try, you see when it's null, and then that would be the end of the.
You could certainly do it that. You could do that first. You could say, isn't even a word in the dictionary first. That might be a good call. In fact, I didn't do that on mine. That's not a bad idea. See if it's in the dictionary first. If it's not even in the dictionary, it's gone, right? Because what's the point of finding it in here if you can't, not even going to be in the dictionary? The fastest part is going to be in the dictionary. So that's not a bad idea, right? But let's say that I wrote a word that is in the dictionary, but isn't in our one up here, right? Then you do have to check and see if it's actually in the board, right? Well, you pretty much could do more or less the same thing, couldn't you? I mean, I like the idea of finding some of the letters first, right? You could go through and say, look, is there even a T in this thing? And then every time you get to a T, you could start. That's not a terrible way to do it. That might save some time, actually, right? Or, let's see, what else could you do? You basically do have to get from, you do have to go and find whether that's in there or not. I forget exactly how I did it in my solver. I'll have to look. Let me look real quick. I completely forgot exactly how I went about and did it. Ran out of space here. See you, Anna. All right. Yeah, question.
Don't know
While I'm
that
doing
this person is not going to be giving you a lot of words. Or a lot,
you can't really assume. They might give you as many words as are in the dictionary. I mean, they could give you any amount of words.
All right.
Whether or not
So
you.
It could just be the easier thing is to check it letter by letter. If there's not many words, then it's not going to take so much time to do that.
Yeah, you could do that. I mean, I think the idea.
T, then go to O, is O in there? Yes, then keep going. T, can you go there? Yes, okay. And then just
Yeah.
go word by word.
Yeah, I mean, I guess so. I mean, you could. Yeah, not a bad idea to go and find the letters first. Let me just see. I forget. Like I said, I kind of forgot how I did it, which might help. Let's see. Oh, this is so slow. Hang on.
And you can't use the Boggle list.
No, you can't. Now, like I said, you could, if you really wanted to, recreate that in your thing. But I don't know that I necessarily would, right?
So when
I mean-
is that bog word list for? Are we not going to call it every time that we run the program?
Well, the bog word list at the end of the program, you want to print out all the bog word lists. At the end of the solver, you want to print everybody in the bog word list out, right?
Basically, you want to do this one first.
Yeah, you want to do well. This is what's going to get called first. The bog word, yeah, that one's going to get called first, right? Well, actually, it depends. You don't have to have the bog solver to do the bog checker, so you actually could do either one. They don't get called necessarily in order. I'll see you later. Bye. Okay. Let's see. Yeah, basically, you know what? I did pretty much the same idea here. Let's see. I basically did more or less the same idea, except that I knew that I didn't have to check all the words. I was only checking basically for one word. So for each one of these letters, go through and see and keep track of which position you're at, 0, 1, or 2. And then check the letter. And before you do anything else, don't bother checking if it's, you don't need to check in any big dictionary now. Well, you will eventually. But for the first thing you can do is just check, hey, is the letter I'm at the right letter in the position in the word I'm at? Which is kind of what you were saying earlier, right? So go to A and go, is it a T? No. No, 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 yes. OK, now we call this recursively. And we say, OK, so now we're going to call it recursively and go down and go to the next letter. Go up to the A. Is the A an O? Because it's the second letter. No. Go by. That'll be a lot faster, right? OK, and then you get to the O, and you go, OK, is the O the O? Yes, it is. We have to now recurse. And then to recurse, is the T and a P? No, 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 no. Yep, that one's a P. Oh, and we've made it to the end of our word. This is a good word. Right? Makes sense? And all you have to do for this is say OK or not. The only thing you have to do for here is say OK or no. Right? The other thing, I still have to kind of figure out what the way Bruce's system checks this. At this point, if I put top, tops, bat, cat, top, are you allowed to have two words in the dictionary, like in your solution? No. So I think when you go through, this one's OK, 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 not OK because it's not in here, not OK because it's a duplicate word. That's probably a good idea. Like you probably should check and see if it's a duplicate word here. I guess I'm not fussed about which way you do it. In other words, check if it's a duplicate word there, or check later and just score it 0. I'll have to check.
That was in the example that it was scored 0, I'm pretty sure.
Did it say no and score 0? 0 no top? Or did it say 0 yes OK top? That was the question, because it would be an OK word in here. Yeah. But it's not an OK for scoring. So I'll have to clarify. I'll have to see I'll have to make a decision on that and see what we do. But that will actually do, it's more or less the exact same thing for the checker, except that a good idea to check and see if it's in the dictionary first. And then second thing, just run through your thing, and then an extra base case will be, look, if I'm not even at the right letter that I'm trying to check, forget about it. Right? And there's no more checking if it's a prefix of the dictionary. No point in that. Yeah?
Does the user's input come in as Boggle?
No, the user's input comes in as words, just straight up words. So word, 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 you're done. Yeah. In fact, it doesn't even have the period at the end, which seems a little silly. They should have done it the same format, but yeah.
So if you check, it's say the word's not in the dictionary, would you amend the string to say have no in front of it, or would you print out?
You would just, all you need to do is print no and then print the word. Okay. Yep, that's all you need to do. OK. All right. What else? The scorer, I think, is pretty straightforward. By the way, we haven't talked about handling Q yet. Let's talk about that briefly. If you hit a Q, it's going to be represented with a Q like this in your bog board. Right? It's going to be represented like this in your boglet. OK? In your dictionary, it's going to be represented as QU. Right? The dictionary has the QU in it. So when you're checking, when you make your prefix, right, you better make your prefix include the QU as part of the prefix. So there's a special case there. Okay? Because you're going to have to check it in the dictionary. Okay? I suppose if you wanted to be really clever about it, you would do all the Q business out of the dictionary. You'd remove everything in the dictionary that starts with Q. Anything that doesn't start with QU, remove it. This would actually be pretty clever. In the dictionary, like if you're reading into the dictionary, just say, I'm not going to deal with Qs. I'm just going to make Qs like this. The only problem, no, you could deal with it later. I was going to say, because we're forcing you to use QUs, anytime you see a Q, you add another letter to the, you just deal with it. But the dictionary could just have words that are really QU, but you actually represent them as QIT, right? That would be quit in the dictionary, but you just search for it. That's not a bad, you could do it. Keep it that way. It doesn't really matter. It's a little bit over the top, but see you later. Yeah. All right. But anyways, as far as handling Q goes, you have to, in the Bogboard, it's going to be a single letter. And then in the prefix for the dictionary, you need to check it with the U if you're not doing something special like that. All right. What else? You guys are tired, aren't you? I'm tired too. Anything else on this one? All right. I tell you what, I will stick around. If you have any other specific questions you didn't want to ask in the group, let me know, and I'll do that. Anything else for the group? All right. Let's wrap it up. Thanks, guys.